Figure 9.3 shows us kind of the activity of what happens in the soil and how the soil can become acidic. One of the ways that the soil can become acidic over time, and that is the entrance of hydrogen into the system. So whenever we introduce hydrogen into the system through those processes that we just talked about in table 9.1, when we introduce those hydrogens into the system, they can go onto these exchange sites, and when they do that, they remove or they replace, and this is the whole idea of exchange, cation exchange capacity, is that exchanges can take place, and when those hydrogens go on, they kick off, quote unquote, kick off other ions, other cations that are on the humus and or the clay, and those go into the solution. Now, if we don't have a lot of rainfall, then those just stay in the solution, and sometimes they go back on and come back off and go back on, and that's just part of the process. Other times, if we have a lot of rainfall, we can have anions that are going to be in the soil naturally, right? Because they're going to be repelled away from the clays and the humus and those colloids that have negative charges. Remember, there are some colloids that do have positive, have anion exchange capacity, so they can actually take anions onto themselves, but the cation exchange capacity of soils usually far outweighs the anion exchange capacity. So usually we have these anions out here in the soil solution. Those can sometimes they can complex with calcium, connect with calcium and form a molecule. And sometimes both of these, the anions and the cations, just simply leach out and they move out of the soil with the water that's moving through the soil after a precipitation event of some kind. So that would increase the acidity if all this process worked just like you see, it would increase the acidity of the soil.